Now I'm going to discuss about how to interface 8253 and 8251 with 8085 microprocessor. Okay, so 8253 is IC which is used for time delay generation or event counting. Okay, so here 8253 and 8251 is going to be interfaced with 8085 microprocessor. 8253 is specifically for time delay generation and 8251 is for serial transmission. Okay, to transmit data from one place to another place, that is one processor to another processor. Okay, so for that, and I'm going to explain the program. So before that, see this. Okay, so this is the cover of the how to connect 8085 microprocessor with this kit. Okay, so this is 8253 and 8251 kit. Okay, so here this is 8253 IC. Okay, and this one is 8251 IC, which is configured in a single kit. So this is 8253 and 8251 kit. This is interfaced, this is connected with 8085 through this cable. Okay, through this cable which is connected with 8085 microprocessor, and this is the cover of this 805351 kit. There they have mentioned control word register address and port address for 8253 as well as 8251. Okay, so this is the control word register address for 8253, and this is the UART address, that is 8251 control word register address. Okay, so here 36 in program. First we are moving 36 to accumulator. This is the control word for mode selection, that is channel selection and mode set control word format. Okay, so for 8253, so this is for 8253 mode set as well as channel selection, because there are 3 channels in 8253. So we have used the channel 0. Okay, its address is C8, it addresses C8. Okay, so 36 is a channel selection as well as mode set control word for 8253, that will be moved to its control word register. So 8253's control word register address is CE. Then we are moving count 16-bit count to timer registers. Okay, so 000A, this is LSB count, this one is MSB count. So then we are moving that to port address. Okay, so it's for channel 0 is selected, so its port address is C8. Okay, so to that C8 we are moving this count values. Okay, so first we are moving mode set control word, and then we are moving count mode set control word to control word register address, which is CE, and then we are moving count value 000A to its port address, channel 0 port address, and up to this it is 8253. After that this is 8251. This is mode set control word format. 4E is a mode set control word format for 8251. Then it will be moved to its control word register address C2, and this is 37, which is also command for sending a 8-bit character asynchronously. Okay, so that is the control word that will be moved to its control word register address. This is the data we are going to move. This data we can change. Okay, so this is the data we are going to move. Okay, so we are going to transmit, this is the data we are going to transmit and going to receive, and that will be moved to accumulator. After that it will be moved to its port address, transmitting, we are transmitting through this address C0. Okay, so then interrupt, this is a software interrupt of 8085. After that interrupt service routine, which is written in 4200, will get executed. Okay, so here in C0 means, so we are moving this 41 to transmitted, we have transmitted. After that we are calling interrupt, then interrupt service routine will get executed. So interrupt service routine is written in location 4200, where we are reading that transmitted data. Okay, we are receiving this transmitted data through this C0 address, port address. Okay, receiver port address is also C0. We are receiving that data through this port address. The transmitted data is getting through this address, and then that data is written in this location. Okay, so here we are getting the data in accumulator. After that that accumulator data is going to be written in this location. Okay, so transmitted data is received and then going to see in location. Here we are transmitting data from 8251 and then getting it in 8085. Okay, so let us check with the kit. So here the opcode for MEA instruction is 3E, and then 36 is a command word, and then out opcode is D3 and CE will be entered, and move MBA A comma opcode is 3E and 0A will be entered, and out opcode is D3 and C8 will be entered. Okay, so reset subset 4100 3E36D3 and then CE3E0A. Okay, so and then D3C8 3E and then 00D3C8 and then 3E4E D3, then C2 3E 3E37 D3 C2 3E, okay, D3 C2 3E and then 41 D3 and then C0 CF. Okay, so and then in 4200 we have to write a subroutine program, reset subset 4200 and then DB C0 32 and then 50 41 CF 50 41 CF and then stop. Then we have to execute both the locations 4100 as well as 4200 we have to execute, and we are going to see this data in 4150. In this location we are going to see this data. In our coding I have given in location 4115 reset subset 4115 I have given 99. Okay, so let us give FF for 55. Okay, so I am changing this data as here I am giving, instead of 41 I am giving 55. Okay, so then I am going to reset and then going to execute both the location. We have to execute reset subset 410 reset go starting address execute, and we have to execute 4200 also. Okay, so because subroutine is available in that location, reset go 4200 and then execute. Now we are going to see the result 55 in location 4150. Reset subset 4150. It should contains reset go starting address execute reset subset reset go starting at 4200 and then execute reset subset 4150, where we have to get 55. Okay, so previous case we have given 99. So now reset subset reset go starting address execute reset go 4200 and then execute reset subset 4150. It should contains 55. Instead of that we are getting previous data. Okay, so let us execute again reset go 4200 execute reset subset 4150, where we are getting 99, because we have given previous data is 99, that is displaying here. Whatever data we are giving, that will be received in this location. Okay, so 55 data we have given. Let us see whether it is available at location 4150 or not. Okay, So this is the previous data which we have given as input, that we are getting in location 4150.